Hello and good afternoon, CSI-158, Section 844 students at Anne Arundel Community College for the second 8-week term in the fall 2014 semester. This is the Routing and Switching Essentials course, and this video is being done to quickly do well, I shouldn't say quickly, but to do a pretty comprehensive tutorial. This is going to mirror our class lecture and in some cases substantially enhance the class lecture that we had regarding Chapter 9 in the Routing and Switching Essentials book, which is on ACLs. And so this first video, I'm going to break this into two videos. One is going to be for IPv4 standard and extended ACLs, and the second video will be for IPv6 ACLs. Okay, so let's go ahead and jump right in. One of the first things that we want to talk about with respect to ACL operations is how to classify traffic as to whether it is inbound traffic or outbound traffic. And so here's how we determine that. When you look at whether traffic is inbound or outbound, and if we look at router 2 here, the way that we want to classify that traffic, it's always going to be based on the point of view of the router, right? Not the host. So a lot of students will become confused because they'll say, oh, well, if the traffic is going outbound from the host, then I would apply an ACL here in the outbound direction. Now, if we were looking at it from the point of view of the host, that this traffic is going out from the host, then that would be correct. However, we want to make sure that we look at it from the point of view of the router. How is the router seeing that traffic, right? So with respect to inbound traffic, and I'll put inbound here, inbound traffic would be traffic that would be coming into an interface before the router has had a chance to internally process that traffic. And by internally process, I mean do a routing table lookup, check the source IP, destination IP, and then actually internally switch and route the traffic out another interface. So traffic from 192.168.11.10 coming this way, this is inbound traffic because it's inbound to the interface. It hasn't been received on another interface and then made its way through the router to come out of that interface. So from the point of view of the router, traffic from 192.168.11.10 would be considered inbound traffic. All right, so what do we consider outbound traffic? So let's come over here to 192.168.10.10. So again, traffic on, or router 1 would look at traffic on this interface coming from 192.168.10.10. That's going to be looked at as inbound. Now, on this interface, traffic from 192.168.10.10 will be looked at as outbound traffic. And the reason it would be outbound traffic is because that traffic from this host coming this direction would be received by that interface, but then it would come internal to the router where a routing table lookup would be done for the source and destination IP, specifically the destination IP, to see where am I going to send it. And if that traffic was destined to come over here, it would have to come out of that interface to get to this network down here. And so therefore that ACL would be applied in the outbound direction. Now, there are two types of access lists that we have talked about so far. Let me clear the screen here. And we've talked about standard ACLs, and we've talked about extended ACLs. So remember, the standard ACLs can only match on the source address, right? And we put it here, match on the source address. The next thing that we need to know about standard ACLs is their numbers range from 1 to 99, and then the standard ACLs also have what's called an expanded range, which is from 1300 all the way up to 1999, right? So these are the ranges for your standard numbered ACLs. And remember, standard ACLs are very simplistic. They match on source address only. Then we have extended ACLs. And the extended ACL range picks up from where the standard left off, and it goes from 100 all the way up to 199. And then again, for the expanded range of extended ACLs, the range picks up at 2000 and goes to 2699. And these are the numbers that would indicate whether your access list is going to be a standard access list or an extended access list. And so let's take a step over here onto a real Cisco router. And this is just simply a Cisco 1841 router that is running 15.3 code. And you might remember this from the OSPF topology that we were tinkering with here in our OSPF video from Chapter 8. So when looking at ACLs, if I type in access list and then question mark, you can see that I'm locked in right now to creating either a standard numbered access list or an extended numbered access list. Right now, there's no way for me to create a named access list. And so the difference between creating a standard numbered ACL or an extended numbered ACL and a standard or extended named ACL is the IP command or argument in front of access list. So let's take a look at some examples here. So if I were to say access list 99 and then do a question mark, you can see that 99 is a standard access list number. Therefore, I can literally permit or deny or put a remark in here, and we're going to see what we can select in terms of the matching criteria. So when I say access list 99, it's always a great idea to put remarks into your access control lists. And the reason for this is not only for you coming back and taking a look at it to try to figure out maybe why did I put that in there or when was it put in there, but more importantly, if someone follows you, you want to make sure that you've properly documented everything in your setup so that someone could step in after you and then easily discern, oh, this is why Travis put this ACL here. So typically, if you're in any type of a controlled environment, you're going to have change control. So what I always like to do is to put a little remark in that indicates not only why the access list was put in, but when the access list was put in, and most importantly, by who was the access list put in. So I would put remark, let's say, per change control number 8675309 on 11/27/2014 by TP bond fee, and then blocking, let's say 192.168.10.10 to web. All right. And again, you've got 100 characters that you can use in the remark. Had I typed in, let's pull this back here. Actually, it'll probably be easier to simply put in access list 99 remark and then the question mark. You can see we've got up to 100 characters. Now, here's something to keep in mind. Again, this is simply a standard numbered ACL. We've put a remark in the ACL. If I do a do show access list right now, we're not going to see anything, because when you do the do show access list command, it does not show the remarks. So in order to see the remarks, I would have to do a do show run, and I'll start with the section, whoops, access lists. Or I should have said access, I apologize. And so now you can see the remark. So if you just did a show run, you would also see the remark. I just trimmed down the output so that we would jump to the section on access list. And so there's my comment. So now it's very easy for somebody following me to see, oh, not only do I have the change control number, which I can then go into the change control system and look up to see what, the full context was around this change. I know the date that the change was made, and I know who made the change. So if I needed to contact TP Bonfy, I could certainly do that. And then again, you could see a quick synopsis, blocking 192.168.10.10 from getting to the web. So let's go ahead and let's build on that. And we're going to do, let me just go ahead and do access list 99. Now, what are our options here for a standard numbered access list? I can deny, permit, or put another remark in. So right now we're going to be denying 192.168.10.10 from getting to the web. And I have web in there, but again, we can only block on source IP. So I'm just going to say 192.168.10.10, and you'll see here, whoops, forgot to put in my deny. And then we've got, I could put in host, but if I just put the full IP in, it'll treat it as a host entry. 192.168.10.10. And now this is pretty nice, right? You see I can use the slash notation. I could use the wildcard setup. So let's go ahead and we'll use the slash notation. I say /32 because it's a host route, right? Or it's indicating that it's a host IP address, so all the bits are there. Or I could just leave it blank like this. Now you'll notice one of the differences here from the packet tracer setup, and if I pull packet tracer up and I look to do the same thing here, so we'll go into from user exec to privilege exec and then in global config mode. So from global config mode, I'll say access list 99. You can see we have the same deny permit remark, so I'll put a quick remark, quick remark here, my comment, and then I'll say access list 99, and we're going to say deny 192.168.10.10. And if I do a question mark, you can see packet tracer only shows you the wildcard bits as an option here. But remember, with the real iOS, depending on your version, you'll have access to the CIDR notation if you'd like to use that. And you'll also notice that it doesn't show me an option to log any error messages that I might receive. All right, so let's go back to the real Cisco router here. So since it's just a host, I can leave the IP address the way it is. I could put a /32. I could also just simply do all zeros, right? But not necessary for a single host IP. We'll use a subnet here in a second. Now, while not part of the CCNA curriculum, the log keyword here is extremely important, because if you want to see entries in your router log where this access list is being matched, in other words, where someone from that host is trying to access, and here we say the web, we would want to see that. So we want to add the log keyword in as well. And there's one final option here, which is very interesting, right? So it says user-defined cookie, max of up to 64 characters. And so they use the word here cookie, and typically, and that has nothing to do with my comment where it says web, but ironically, typically people associate the term cookie with web traffic, right? Or HTTP or browsers, caching cookies so that when you revisit a site, you have information that's already cached and it's there and it comes in the form of a cookie. A more appropriate term here is tag. And it's interesting, you'll see that when we set this up, Cisco will refer to it when I do the show access list. It'll actually show it and say that it's tagged. So they call it a cookie here, but know that what we would be doing is we would be tagging the log entry. Now, why would I want to tag the log entry? If this is a really busy router, and let's say I had a shell script, and I wanted to make sure I had a predefined 100% the same every time string of characters that I could search on, so that maybe, let's say every 30 minutes, I'm parsing the logs on this router to check to see, is the individual at that workstation trying to access the internet? So let's take a look here at what we would put for a cookie. Again, the cookie it's simply a tag. So it's going to tag every match of this rule. When it inserts it into the router log, it's going to add a user-defined tag onto the end of that log entry. And so I've got 64 characters. You want to make sure that you're brief, and I'm going to do all caps to differentiate these, right? I want to make sure that this is meaningful, it adds value, and that it differentiates the other entry it's differentiated from the other entries in the log. So what I would say here is we could say deny underscore 192.168.10.10 HTTP, and we could leave it at that. So when I do a do show access list, you can see that it doesn't say cookie equal, it says tag equal. And as we'll see a little later on, this tag shows up in the log message that comes to your console or that gets buffered in RAM, so that if you wanted to search on this later, I've got nice easy string here that's going to be the same every single time, so I could get a count of how many times it's hit, or I could just see simply if that rule has been matched. All right, so now let's do a different one here. Let me go ahead and say access list 99, and we're going to permit, and let's say we're going to leave a subnet 192.168.11.0. Now, I would not want to leave that all by itself there. So what I can do is I can say /24. So I can use the CIDR notation here, right? If I had another subnet, let's say 192.168.55.128, right? And that's the subnet ID. That would tell me that this is a /25, right? If we've taken a /24 and carved it up, I could say /25. If I had a point-to-point link, I could say 192.168.168.0 and then /30, right? So for a point-to-point link. Now I could also use the wildcard bits. And this is critical because this is something that you're regularly tested on throughout the CCNA, the Routing and Switching Essentials course, and as you move on and deal with the routing protocols like OSPF. So if I were to say access list 99, and I'm going to deny something now, and I want to deny the 172.16.16.0, and I want it to be let's say a /24. So at this point, how do I figure out what the wildcard bits are? Now the CIDR notation is very nice because it alleviates figuring out the wildcard bits, and it allows the router to make that calculation for me. However, on the CCNA curriculum, we don't have that luxury. We have to know how to sort out what the wildcard masks will be. So, in terms of the wildcard mask, right, it's often referred to as the inverse mask, and the reason for that is because when we have normal subnet masks, so let's say I have a 192.168.20.0/24. So we know that the /24, that's our CIDR notation. In dotted decimal notation, that would be 255.255.255.0. And so the subnet mask, when the bit value is on, which means we care that value is on, it's a 1. So it's 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot, make a better dot here, I don't want it to be a 0. 3, 4, 5, 6, 7, 8 dot 0, right? 2, 3, 4, 5, 6, 7, 8. So when the bits do not match, right? And so when we don't care with net mask, right, with the dotted decimal net masks, we use zeros to say we don't care, right? It could match anything. However, when we want to signify a match with a subnet mask, we use the 1. So the reason that we say a wildcard mask is the inverse of a subnet mask is because it's inverse with respect to the logic, where we use a 1 to say we don't care. We don't care if it matches, and we use a 0 to say that it does, that we do want it to match. So the wildcard mask for 255, 255, 255.0, would be 1, 2, 3, 4, 5, 6, 7, 8, and this is in binary, right? This is what the net mask would be in binary. 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 1, 1, 1, 1, 1, 1. So 1, 2, 3, 4, 5, 6, 7, 8. So this would be I'll just put WCM. This is our wildcard mask. Because with the wildcard mask, when we say we want matches, we use zeros. When we say we don't care what the value of those bits are, we use 1s. And so in looking at this, this would be 0.0.0.255, right? And so even in dotted decimal notation, it is the inverse. So where we have values of 255, we have values of 0. Where we have a value of 0 in the subnet mask, we have a value of 255 in the net mask. And so this is why you'll hear the term inverse mask used in order to describe a wildcard mask. Now, something to keep in mind. This is relative to IPv4. And I know that I'm going to be doing a second video on IPv6, but please note that unlike IPv4 ACLs, where we use our wildcard masks, right? Unlike IPv4, IPv6 ACLs do not have wildcard masks. And it's very similar to when we were doing summarization or subnetting with IPv6. So with IPv4, when you do your subnetting, you say, this is my subnet mask. However, with IPv6, it's not a subnet mask. Remember, we refer to that as the prefix length. And so just like with subnetting and summarization with IPv4 and IPv6, when we talk about wildcard masks, you have wildcard masks with IPv4. However, it's the prefix length that's used with IPv6 that will indicate how much of the IPv6 source or destination address should actually end up being matched. And so we'll talk about IPv6 in the follow-on video. So again, back to IPv4 and inverse masks, right? So that we say the wildcard mask is the inverse because it's the opposite. And you can see it's the opposite in binary as well as the opposite in its dotted decimal notation. All right, so how do we end up calculating wildcard mask values? And so the text did a really good job. There were some simple examples and then some more complex. So let's take a look at the very straightforward examples. So if I had 192.168.10.0 as my subnet, and let's say that this is a /64. It's a prefix link. So it's a /24, right, for a regular Class C. So I know that the CIDR notation /24, my dotted decimal notation will be 255.255.255.0. So there's a very simple rule in a very simple way to calculate what your wildcard mask will be, and that is simply by taking your subnet mask and subtracting that from all 255s. So what would that look like? So I would do 255.255 dot, whoops, paused on me there, dot 255.255. So the all 255s, and I would subtract my subnet mask. So 255.0. And what do I get? 0, 0, 0, 255. Put the decimal marks back in there. And that is my wildcard mask. So it's a very simple way to calculate the wildcard mask. And this works fairly easily when you're dealing with simple scenarios like this one right here with a /24. So let's take a look at another scenario. And let's say that we have 192.168.10.0/23. Right? So it's not a /24, now it's a /23. So my dotted decimal notation now is 255.255.254.0. And the same process applies. We simply put down the all 255s. Let me back that one out there. There we go. All 255s, 255.255, and we subtract our subnet mask. 255.255.254.0, and now we end up with 0.0.1.255. Now, we know that since this is a /23, it could be broken into 2 /24s, and so the range that we're matching, right, is a little larger than 10.1 to 10.254. It's going to be from 10.1 all the way up to 11.250, and I'm talking about the usable IP address space. But this will be our wildcard mask for that subnet mask right there, right? Once it's converted. And so that works out relatively easy for you in terms of how do I go from a subnet mask to a wildcard mask. Now, there were also a couple entries where they made it a little more challenging with respect to the ranges of addresses. So let's do one last example here. So if I had 192.168.20.0, and let's say that for whatever reason I wanted to use a subnet mask of 255.255.240.0, right? So this would be a /what? So to get 240, let's review our bit positions really quickly. So we've got 8-bit positions where it's 128, 64, 32, 16, 8, 4, 2, and then 1. So to get 240, I would need that bit position, 192, 224, and 240. So this would be a /20, right? So we have 16 bits, 8 bits, 8 bits, and then 4 additional bits to give us a /20. So if I were to say 255.255.2, oops, keep that on there, 255.255, again, very straightforward process, and I'm going to subtract my subnet mask, 255.240.0. So what do I get? 0.0.15.255. So that would be the wildcard mask for a /20. Now, the question that a lot of students have is, well, how do I know, when I look at the wildcard mask, how do I know which networks I'm actually matching? Because I can see that I've got a /20 here, so I know it's more than just 192.168.20, dot zero. And so this kind of goes back to our conversation on summarization. So let's take a look here. Let's look at if I had 192.168.32, go back one, .32.0/24, and I wanted .33.0/24, and I wanted .34.0/24. So I want a wildcard mask that's going to represent these three networks. So the question is it possible to represent these three networks and only these three networks right here in a single ACL? And so this is why summarization becomes critical. So one way to determine that is to do our summarization. So our interesting octet is the third octet. And we're going to go ahead and take a look here and say 32 is going to be 128, 64, 32, 1, 2, 3, 4. And 33 would be 0, 0, 1, 0, 0, 0, 0, 1. And 34 is going to be 0, 0, 1, 0, 0, 0, 1, 0. And so let's summarize this. We know that the first 8 bits here and the first 8 bits there match, so we have 16 bits that match. How many additional bits? So we've got 17, 18, 19, 20, 21, 22. However, when we get down to the 23rd bit, it no longer matches. So we take a look at this and we say, what's our summary? And you remember from summarization that this bit position, since it's on, that value shows up in my summary. So my summary is going to be 192.168.32.0/17, 18, 19, 20, 21, 22. So it's /22, right? However, when we look here, how many bits did not match up? So the last 2 bits didn't match up. So remember, if you take 2 to the number of bits that don't match up, that's going to tell me how many networks I'm actually supposed to match. So here we get 2 to the 2 is 4. So we're missing 1 network. So even though this is the correct summary, and this summary right here correctly will summarize these 3 addresses, there is a 4th address that's not here. So how do we figure out what that 4th address is? We simply look at these last 2 bit positions and make sure we have every possible combination represented. So 0, 0, 0, 1, 1, 0, but what are we missing? We're missing 1, 1. So if we're missing 1, 1, what would 1, 1, along with these other bits over here, what would this equal? And this is our 4th and missing final subnet. So we would say 001, 00011 equals 32, 33, 34, 35. So in effect, we would be missing 1 subnet. So let's step over to this page over here. So we were at, give us some more space. So we had 192, and that is a horrible 192. So we had 192, 168.32.0/22. This was our summary. So my wildcard mask is a /22. So what is that in dotted decimal notation? It's 255.255 dot, and remember it's a /22, so that means that we've got 2 bits that aren't being borrowed. So 252, right, will be the value in this 3rd octet because only 6 bits are used. So again, the 128, 64, 32, and these are the values of those bit positions, 4, 2, and 1. So if 6 of those bits, so these 6 bits, these 8, but we only have 6 after that, right? Because 8 plus 8 is 16, and then plus 6 is 22, so it's going to be 1, 2, 3, 4, 5, 6. So these 2 guys are not on, so we subtract 3 from 255, and it gives us 252. and then it's going to be .0. So that is my subnet mask. Let's put SM for subnet mask. So how do I do my calculation? 255.255.255.255, and I'm going to subtract my subnet mask, 255.255.252.0. And what do we get? 0.0.3.255. And so this subnet mask, or I'm sorry, this wildcard mask correctly represents that subnet mask. However, as the system administrator, you need to understand that that wildcard mask is also going to be allowing or denying, whichever, permitting or denying, the network 192.168.35.0/24. So that network is also in the range of this wildcard mask. So, and I'll do up an example here a little bit later on to prove that this is in fact the case, that this is what you're going to see happen, is that while it will correctly identify and correctly work on the 32, 33, and 34, it's also going to pick up the 35. And this is why it's very important to know how to summarize addresses. Okay, so that's definitely a good set of examples on the wildcard mask and how you calculate the wildcard mask, remembering that with the wildcard mask, the ones mean I don't care. So it's the inverse of a subnet mask. All right, so let's come back over to router 6 here in our example. So if I do a show access lists now, what do we see? So we have one standard IP access list. The number on that access list is 99. We can see here that our first statement in the order is to deny 192.168.10.10. We're going to log any successes on this match, and we're also going to add a tag onto those log entries to make sure that we have a constant predictable string of characters on which to search if we wanted to at a later date, and it also differentiates those log entries from what you would normally see. And then we've got sequence number 20, permitting the 192.168.11 subnet /24. We've got sequence number 30, permitting 192.169.55.128, which is a /25. And you can see, remember, we put the CIDR notation in, but look what happened here. So if I was to create another entry and say access list 99 permit 10.10.10.0, and this was a /28, if I said /28, right, I use the CIDR notation, but when I do a do show access lists, whoops, extra character there, you can see that the /28 is converted for me, right? And this also may be one reason why the packet tracer does not allow you to do the CIDR notation, because if you can do the CIDR notation and you know what that is, you could easily just put a bogus entry in here and it would give you the answer to what the wildcard mask is actually going to be. So it's very nice. We give it the subnet mask, and then it provides the wildcard mask for us. All right, so this has been a standard numbered ACL. What if I want to manipulate this standard numbered ACL? Let's say that I decide that we no longer want to permit the 192.168.168 network, sequence number 40, right? So in order to manipulate the access list, there's two ways to do it. I could pull up Notepad or some other text editor. I could cut and paste the access list into that Notepad editor or that text editor, kill the access, delete the access list, and then cut and paste it back in. So let's take a look. So here's how you would do that. So if I do a do show run section access, I want to see my access list. And remember, this is what we're going to cut and paste in. We're not going to cut and paste in these access numbers. So I would go ahead, I would copy, and if I'm not mistaken, I have my, and I'm not sure that the CentOS would work. Let's see. There we go. I'll just come over here to my Mac, right? So if I'm on my Mac here, I could go ahead and pull up just the VI text editor, and I'll say ACL 99, right? So I would paste it in, and this is how you would do it in Notepad, right? A little easier in Notepad. So, but I'm going to say, okay, we're going to say that maybe it's now the 27th of December, different change control number. We'll say that the change control number is just that, right? I'm going to put a new comment in, and I realize I don't want to permit the 192.168.168. I want to deny that subnet, right? Or specifically, we've got a .3 on there. So this is a 252, so it's a /30. So I'm going to deny that network access via this ACL. So I've made the change, right? So now I'm going to save the change. And again, this is in Notepad much easier because you're cut paste, but here we're going to do just using VI. So now what I would do is I would grab this, and I'm going to copy it. And remember, this is my change, right? Because now I'm denying that access list. So let's come back over to the router. So there are two methods to manipulating or to changing your standard numbered ACLs. So this is the first. So I'm just simply going to say no access list 99, right? And now this is going to wipe this ACL out. And to show you, if I were to do the do show run on section access, we get nothing. So what I want to do now is I want to go ahead and add that ACL back in by pasting in the new entries. And there we go. So now I've pasted the new entries in. So literally the first method to manipulate the access control list is to cut and paste the access control list into a text editor, and then make your changes, and then simply delete the existing ACL, and then cut and paste the edited ACL into the router. So now when I do the do show run, I got to go back up through these commands, section access, you can see that our access list is there along with the change. Now, a quick note. I highly discourage you from trying to use Microsoft Word because there are control characters that will oftentimes be placed in when you cut and paste. And the router does not like those control characters. So again, if you're good with VI, or you're good with the Vim editor, or you have Notepad readily available, that is how I would highly recommend you do this type of a modification. Now, do I have to kill my ACL? Do I have to delete the ACL and then cut and paste and then drop it back in? No. There's a second method to do this. And this is where the sequence numbers become important. So if I were to type in do show access list, I should have probably just typed it. There we go. Oh, that's not what I wanted to do. So we're going to go ahead, and thankfully it's in the buffer, or it's not in the buffer. So we're going to have to go get it again here real quick. I was actually looking for the show access list 99. So we're going to copy this. We get the bonus lab here, and I'm going to paste it back in. All right. So if I do a do show run section access, we can see this access list, right? So there it is. We've modified it, but there's an easier way. If I type in do show access list 99, you can see that we have sequence numbers that are at the beginning of each of these access control entries. Now, it's very important to remember the remark does not receive a sequence number, right? And this is the sequence in which these statements are also evaluated. So if a packet were to hit an interface where this access list was enabled, it would first check to see, is the source 192.168.10.10, right? If it is, I'm going to deny it. The next thing it would check, is it 192.169.11.0? If it is, it's going to permit it. And the key thing to remember is the first statement here that matches, that is the last statement that gets executed. So if I come in and I match on the deny, the packet is dropped immediately, meaning to say that it is not going to evaluate the subsequent statements in the access control list, right? These access control entries, these ACEs, are not evaluated if the first ACE is a match. Likewise, let's say that the packet is from 192.169.11.55. The first access control entry, the first ACE, it doesn't match. So then it comes to the next ACE and it evaluates. It says, does it match? If it matches here, that's it, you're done. Which means sequence number 30, 40, and 50 are never evaluated against that packet. Okay, so I've got my entries in here, are sequence numbers. So we looked at the first method to manipulate your access control list, right? Which is simply removing with the no access control access list, whatever the number is, and then cutting and pasting the output into a text editor, preferably Notepad or VI, Vim, and then cutting and pasting it back into the router. The second method to make a modification is by using the sequence numbers. However, to do that, I need to use the IP keyword in front of access list, right? And you'll see it's going to ask me, are you talking about an extended access list or a standard access list? So in our case, it's a standard access list, and now we need to tell it. You'll notice it doesn't even show the extended access list range here. So if I had typed in extended in the hopes that I was going to edit access list 99, you could see that if I typed in 99 and hit enter, it's going to say invalid access list name. So again, we have a standard access list here, and it's 99. And now I am into the named and numbered access list, the standard named and numbered access control list editing feature, right? So the command mode here. So what I can do now is I can pick off the specific ACEs that I wish to manipulate. So let's go ahead and get that pulled up here. So do show access list 99, because I want to have that handy. So we had talked about, let's say that last entry, 50. If I wanted to remove that last entry, 50, I could simply say no 50, right? And if I back up and do the question mark, you can see I can be more specific. I can remove the remark, or I can just pull the sequence number and say no 50, right? So now when I do the do show access list 99, sequence number 50 is now gone. So what happens if I add in, I want to add a new entry in. So let's say that between 10 and 20, I want to add a statement in here that denies, let's say .10.11. Maybe I added a new workstation to that segment. So I would say 15 deny 192.168.10.11, and do I have the same options available? I sure do. I can log it, and I can also tag it, and we'll go ahead and not be too creative here and cut and paste, and I'll just come back and say we're going to deny that. So we're going to tag him as well. So now if I do a do show access list 99, you can see that we have sequence number 10, but now the second sequence to be evaluated is 15, right? And we've inserted that in here. What if I picked a number that was already taken? Let's say I didn't realize that 40 had been taken. So I'll say 40 permit any, or actually let's just do 10.10.10.122, right? And I hit enter. You can see that the the router is smart enough to know that that sequence number already exists. So what happened? Did that change the access list at all? It did not. So we received an error message there. And so that's how you get in, and this is how you can manipulate standard numbered or named ACLs, is by preceding the access list with IP back at global config mode. All right, so hopefully you've got a little more confidence and a little more clear understanding as to how we manipulate the standard ACLs. So let's take a look at the placement. Now that we kind of understand how to create these ACLs, let's come over here to Packet Tracer, and this is a little easier to demonstrate. We have two hosts here and where we're going to put the ACL. So let's check. I'm on 192.168.10.10. Can I ping my counterpart over on the other subnet, 192.168.11.10, and then likewise, let me see if I can ping back in the other direction. So ping 192.168.10.10, and we had to ARP out there, and we have full connectivity, right? So each PC can ping the other PC. So we've got success here. So if your boss came to you and said, I need you to put an ACL on the router that is going to block 192.168.10.10 from communicating with 192.168.11.10, and it needs to be a standard ACL, right? Let's just keep it simple and do a standard ACL. So what you might do, and this is definitely in error, but let's take a look. What you might do is say, oh, okay, well, I'm going to come to this interface right here. I'm going to block that traffic right here. If you want to ping that web server out there, 209.165.100.10, from PC 10, we'll just say 192.168.10.10. So we've got connectivity out there. So I'm going to hop on this router, and in terms of placement of ACLs, remember that it's a general rule, and the book clearly uses that verbiage, a general rule. It's not mandatory, right? But it's a general rule, and you're going to see why it's a general rule here in a second. So the general rule is that with standard ACLs, you want to place the standard ACL as close to the destination as possible. So what does that mean? So this is the source, right, of my standard ACL. This is the destination. So I'm trying to stop this guy from communicating with this guy. So we're going to go ahead and mistakenly, we're going to put it here because we're going to show you some different impacts that the ACL will have if you put it on the wrong interface. So we have a standard ACL. We're trying to stop this source from talking to that destination, right? So what does that mean? Which interface on these routers is the closest to the destination? It's that guy right there, okay? Because, and what I'm going to demonstrate is if we don't follow that best practice here, right, that general rule, if I put the ACL here, I'm blocking this source right here. So that means that this PC will no longer be able to even get out of that subnet, which means he will no longer be able to ping that web server, right? And I'll just put www. So we're using this guy as a web server. So let's see how that could mistakenly be done. So if I'm the junior network administrator and I say, okay, I'm going to go ahead and create that standard access list. So we'll go from privilege exec to global config. I'll say access list 1. And you wanted me to deny 192.168.10.10 from getting over to 11.10. 192.168, whoops, .168.10.10. .10.10. All right, so there's my access list. So if I do show access list, you can see that I have a standard access list. The access list number is just simply 1 because it's standard, and that's a single statement, right? You told me I need to stop 192.168.10.10 from getting over here to 192.168.11.10. All right, so now I'm going to apply that to my router 1 gig 00 interface. So we'll do interface gigabit Ethernet 00, and I'm going to say IP access group. And if I do a question mark, you can see it just wants the access list number, right? Standard or extended, or if it's a named ACL, and we're going to talk about those next, you put the name in. So IP access group and 1. So that's our ACL. So over here, you can see that this is working. I'm able to ping over here. And so what I'm going to do is I'm going to real quickly start the ping and then apply the access list and see what, oops, we forgot. Which way is it going? Is it inbound to that router interface, or is it outbound to that router interface? And so remember, when you're trying to determine in and out, it's from the perspective of the router. So from this router's perspective, would traffic from this PC be coming inbound or outbound? Well, if it's from the perspective of the router, it's clearly inbound traffic. That traffic is coming into the router 1 interface gig 00. So we're going to apply that inbound. So let's try this one more time. Got a little bit ahead of myself there. So as you can see, we still have access to the web server, or what we're using as the web server. So I'm going to start. So it's inbound. So I'm going to start the ping, and then I'm going to apply the ACL, and you're going to see how quickly it picks up and stops. So it looks like those pings got through before I was able to apply the ACL. So the traffic now is still going through. So I put in IP access group 1 inbound, and my statement is deny host 192.168.10.10. Now let's make sure we put it on the right interface. Do show IP interface brief, and it is not on the right interface. So even though I've created the ACL, right? The ACL exists. I've put it on the wrong interface. We have to get it on the right interface. So now let me switch interfaces. Gig 01, right? So IP access group, whoops, access group 1 inbound, and let's try that again. So I'm going to kick off the ping command, come over here, and look at that. As you can see right over here, as soon as I hit enter on that access list, the traffic is now being dropped. So remember, we've done this incorrectly to prove a point. So if you were the system administrator, you would come over and maybe you're going to check and see, okay, can I no longer get to 192.168.11.10? That's true. You can no longer get to the destination host that you're trying to get to. If that was all you checked, you would be waiting for the user of this PC is going to come to you at some point and say, hey, I can't get to the web anymore. And the reason for that is we've applied the ACL not only on the wrong router, but on the wrong interface, right? So the user's going to come to you and say, hey, I can't get to the web. So you're going to hop onto that PC and say, I don't think so. We did an ACL, but we only stopped you from getting to 11.10. So 209.165.100.10, sure enough, the user's right. We've cut that access off. And so here's where a remark would be very critical, to say who did it, what the change control number was, to check and see, what was the intention of the change. So then maybe your senior network administrator is going to become involved at this point. So he's going to come in and take a look and say, hey, listen, I see what you guys did. We've got the ACL. Whoops, I'm going to clear that out. The ACL has been put on the wrong interface, and it's been put on the wrong router. So you guys need to put it on router 2. If that was the only guidance that he gave you, there's still margin for error here. And let's see where that margin for error comes into play. So the junior administrator hops back on, and I'm going to say no access or no IP access group 1 inbound. And then you have your user check. Can you get to the web now? Okay, that's great. I can get to the web, but can you still get to the PC that we're trying to block you from getting to? You can still get there as well. So we want to stop that. So the senior admin told us, hey, we're on the wrong router. So let's hop off of router 1. It's got to be router 2. So again, I'll go from user exec mode to privilege exec. into global config, and I'm going to say we need a new access list over here. So access list 1, and I need to deny 192.168.10.10, and we're going to apply a standard ACL, numbered ACL, and we're going to apply it to router 2. So if I go into the serial 010 interface, which is this interface right here, right, we're going to end up with the same problem, because the traffic will be considered inbound, so it'll be an inbound ACL as well. However, it's going to get dropped right here. The router never has a chance internally to process that traffic, right, do a routing table lookup, and then try to send it out an interface. So from this perspective, right, on router 2, this would be outbound on that interface, and it would be outbound on that interface. But the router never gets the chance if the ACL is applied here as an inbound ACL. So let's misconfigure this ACL one last time. So I'm going to say IP access group 1 inbound on that serial 010 interface. So let's check. Can I ping the host still? I can. So I still have access to the internet. Do I have access? Good. I've got access to the internet. So now we've improperly applied the ACL one last time. So let me ping the internet here, and then real quickly we're going to run that command. Whoops, I forgot to hit enter. So as you can see, we've blocked connectivity to the internet. However, we've also blocked connectivity to the host. So again, by placing the ACL here on this interface on router 2, we've basically said anything behind router 2, this host is not going to get there. So we learned from our last mistake when we worked with our senior administrator in this scenario, and we realized, oh, you know what? We've put this on the wrong interface again, because we've checked now, and this guy can definitely no longer get to the web. So let's pull that ACL off that interface, and let's go ahead and place it on the right interface, the proper interface here. And let me make sure, do show IP interface brief, that it is the interface I think it is, which should be, yes, gig 01. Okay, so let's get it on the right interface. So where do we stand right now? I can ping the web server, and I can still ping that host. So we need to get that access list on the right host. So if I do a do show access list, we've got standard access list 1 denying host 192.168.10.10. You can see we've had quite a few matches already, right? It's also showing us how many matches we've got. So let's get it on the right interface. So let's go to gig 01, and we want to do the IP access group command. But now which direction? So again, from the perspective of the router, right? From the router's point of view, traffic from this host, if we're applying the ACL to that interface, that traffic would be coming this direction into that interface, and the router is going to have to do a routing table lookup, internally switch that traffic out that interface. So that traffic is going out of that interface, therefore it would be an outbound ACL to deal with traffic from that host. And again, a common mistake students make is they say, oh, the traffic is coming inbound to the destination, therefore it's an inbound access list, and this is incorrect. Again, from the perspective of the PC, sure, the traffic is coming inbound. However, the ACL doesn't care about the perspective of the PC when we're applying it to a router interface. It's all about how does the router see that traffic? What does that traffic look like to the router? And here it's outbound. So let's go ahead and add that access list. Whoops. Add that access list outbound on that interface on router 2. So again, our ping test here. So I can ping the PC. Let me go ahead and kick a ping off, and then come down here and quickly apply that, and you can see that one packet got through, and then everything else now is going to be denied. And so this is what I mean when I say that when you're applying the ACL, the interface, and more importantly, the router on which you're making that application and the interface, that it's very critical that you understand not only the inbound and the outbound semantics, right, or the subtleties with which do I choose, but that you also understand that this is why you want to place standard ACLs as close to the destination as possible. That way you don't end up stopping traffic from this guy from getting out to the web, right? So this is as close to the destination as we can get, and it allows his traffic out to the web. That's what we want, right? And again, that's a general rule. It is not a hard mandatory rule. It is a general rule, and this is why. Where that would not be a general rule is if your boss came to you and said, hey, the user on this PC, he is not to leave this subnet. None of his traffic should go past the router. In that instance, that's where the standard ACL that we applied inbound here would come into play. And that would also sort of break that general rule of placing it as close to the destination as possible, right? So, but again, there are use cases where that may be required. However, in general, standard ACLs as close to the destination host that we're trying to stop traffic from getting to, that's the interface on the router that we want to apply that ACL. All right, so that takes care of our standard ACLs. Again, the packet tracer is very good for simulating the host type traffic because we can drag and drop hosts out there very easily. So let's go ahead and quickly take a look at standard named ACLs, right? So we go from user exec to privilege exec, and then we go into global config mode. Now remember, I can do access list and a question mark, and you can see obviously many more choices here with a real Cisco router. And this is the numbered, right? So if I don't want numbered, I want a named access list, I simply precede the access list command with IP. So IP access list, and now when I do a question mark, you can see it's going to ask me, do you want to have a standard named ACL or an extended named ACL? And so we're still talking about standard ACLs here. So let's say IP access list standard and a question mark. And this is what happens. The number for your standard ACL becomes the name. So I would say IP access list standard 87, right? And a question mark. So that is the name of the ACL. And so it's literally the name of the ACL is just the number. So there's not really that big of a difference here. So if I do a do show run section access, you can see that we've got access list 99. Let me put some statements in here. So we'll say, what are we going to do? Let's put a remark. My test named ACL, or my test named standard ACL, right? And then I'll put deny 192.168.14.0/24. Oh, whoops. Let's make sure we get this right. And we'll just go ahead. So here, it doesn't allow us to put that CIDR notation in here, so we would have to drop in 0.0.0.255. So now if I do a do show access, ACCESS, access lists, you can see we have standard access list 87 and standard access list 99. So with standard access lists, there's really no difference, right? Even though we go into the IP access list configuration mode and we end up here under standard named ACL configuration mode, the ACLs are still, the names are the numbers. So it really doesn't buy us much with a standard ACL. Let's go ahead and talk about extended ACLs. So again, I can do an extended ACL numbered from global config mode with just simply the access list command, and I'll give it an extended access list number. We'll say 101. Now, you can see we can also do remarks, permits, denies, and dynamic. Dynamic is something you can deal with, you'll end up dealing with later on as you move on. But let's take a look at a deny. So what can I deny? As you can see, it's much more comprehensive, because when we're talking about the extended ACLs, the reason that we say extended is because there's a far more extensive or extended set of characteristics that those ACLs can match on. And specifically, we can match on protocol type, right? You can match on the protocol number, as you can see here, right? Here are the protocol types. We can, in even OSPF, EIGRP traffic, we can differentiate that traffic. So if I were to say deny TCP and then do a question mark, you can see that now I'm going to say I'm denying the protocol TCP, and the source address, let's say it's going to be 192.168.10.10, because we'll go back to that example in Packet Tracer we had earlier. So I'm going to deny the single host 192.168.10.10. If I do a question mark, you can see we have to do the wildcard bits, and we'll say 0.0. And now I can do a destination IP. So remember, with the standard access control list, we could only match on source IP. And so we would have been done here without that TCP argument. However, with an extended access list, we can actually now not only work with the source IP address, but the destination IPv4 address. So I'm going to say that he's not allowed to get to 209.165.100.10. So in our example, we're going to say we're blocking him from the web server, right? However, I can put another 0.0.0.0, and now I can actually pick the destination TCP and UDP port. So if I just hit enter now, all TCP traffic from 192.168.10.10 that was going to 209.165.100.10 to the web server, all TCP traffic would be done. So TCP, what uses TCP? SSH uses TCP, HTTP uses TCP, HTTPS, Telnet. So anything that used TCP right now would be denied. However, let's say your boss said, hey, you block 192.168.10.10. It's not allowed to access any web traffic from the web server. He can still Telnet and SSH to it, but we just want to stop any regular HTTP traffic. So that's where I can say equal, and if I do a question mark, you can see that you've got a very large selection to choose from, and it's really nice. They put the port number out here on the far right, and you can tie that back to the alphabetic listing of just www. So I'm going to block web traffic. Let's say you wanted to block web traffic and Telnet. I could say equal to 23, or I could spell Telnet out. So what does this look like now if I do a do show access list? What do we see now? So we've got a standard access list here that we created that was named, but again, with standard access lists, naming them, you're just simply using the number as the name. So it's really no different than using just the number. However, with the extended access list, you can see the number is 101. We've got our sequence numbers here, 10 and 20, and we're just simply denying this individual host from getting over to the web server via HTTP or Telnet. So if I tried to access that web server via HTTPS, that's going to work. Or if I tried to access it via SSH, that is also going to work. Okay, so now what we're going to do is we're going to transition back over here to Packet Tracer, and we're going to add a little more sophisticated extended ACL to router 2. So let's go ahead and say no IP access group 1 out. So we're going to remove that. So your boss comes to you and says, I want you to make sure that nobody, or that 192.168.10.10 cannot telnet to router 2, right? So here's router 2. So this is 192.168.10.10. Let me see. Can I telnet over to router 2? And his interface is 10.10.10.2. I get the prompt, right? I put the password in, and now I'm on router 2. So I can go, oh, no password is set. So, but I can still get onto router 2. We do not want that. So your boss tells you, do not let people telnet from this workstation over to router 2. All other traffic, we want to get to router 2. And this is where the extended ACL comes into play. So on router 2, we're going to go ahead and say access list, and we're going to say it's going to be number 101. And we want to deny, and you do a question mark here, TCP, right? Because Telnet is a TCP-based protocol. From the source, 192.168.10.10 and 0.0.0, oops, 0.0.0.0. I could have done that, or to make it easier, I could have just said host 192.168, whoops, 168.10.10. So the host keyword there basically says that the wildcard mask is going to be all zeros. So by instead of having to do 0.0.0.0, I can just put host in there. So we'll say host. So access list 101 is going to deny any TCP traffic from host 192.168.10.10 over to host, and it's going to be the router 10.10.10.2. Now, if I stopped right here, I would be denying all TCP traffic. That's not what we want. We want it to be equal to Telnet, right, or port 23. So again, can I still Telnet over here? So if I exit out, can I Telnet there? I can, because creating the access list isn't enough, right? Now I need to apply it to the router 2 interface. And so what interface is that? It's the serial 010 interface. And have we overlooked something? We have, but we're going to come back to that in a second. So interface serial 010, and I'm going to say IP access group. I'm going to add this access list, which is 101, and would it be inbound or outbound? So we know it's going to be inbound because it's going to hit this outside interface here, right? It's not going behind the router. We're stopping it from getting into the router, right? It's not going to get processed, or there's no routing table lookup and internal switching of this traffic. We want to catch it on that interface. And again, standard ACLs, remember, where do we apply those generally? Generally, your standard ACL is going to be applied as close to the destination as possible. Here, we're going to try to apply the ACL, the extended ACL. The rule is typically as close to the source as possible. So let's apply it here. We're going to break the general rule, and then we'll switch it, and we'll apply that general rule. So we're going to say IP access group 101 in on the router 2 outside interface. So, oh, whoops, we'll pull up the command prompt again. So now I'm going to try to telnet over to 10.10.10.2, and what happens? I can no longer telnet to 10.10.10.2. Now, is that the most efficient way to do it based off the general rules? Well, no, because extended is as close to the source. We would want to put that here. We wouldn't want that traffic. If it's going to ultimately end up getting dropped over here anyway, why would I want that traffic to come across my serial link here? So what if it wasn't telnet traffic? What if it was video traffic? I mean, it could saturate this link. Again, it's unnecessary traffic out on this link that we don't want. So this is where we would want to place that ACL. So let's make that correction here. So on router 2, let's pull that ACL off of here, and let's come over to router 1, because again, we want to follow the general rule. And can we telnet there now? We can. So we're going to come back though, we'll break that connection. So let's do from user exec to privilege exec into global config. Whoops, into global config mode. So access list 101, and we're going to say deny TCP traffic from the source host 192.168.10.10. And actually, let's put that host keyword in there. Going to host 10.10.10.2 equal to 23. And now let's go apply that on that gig 01 interface with IP access group 101 inbound, because that traffic will be coming in from 192.168.10.10. So can I telnet now? All right, I cannot. So I've blocked access to telnet, and I've done it in a best practices way. Now, let's get back. You may be sitting out there screaming at the monitor saying, wait a second, what about all the other traffic that's trying to get over there? So, well, what if I ping 209.165.110? Well, that traffic's broke. How can that be? Because you just told me that we're only denying 23, TCP traffic over to 23, and ICMP is not TCP based. So why is it broken? So now this brings us to one of the biggest gotchas when dealing with access control lists, and that is the implicit, and by implicit I mean implicit's the opposite of explicit. So when you explicitly define something, that means we would actually type it in and explicitly define the access control entry. However, at the end of every access control list, whether it's extended or standard, at the end of every ACL, there is an implicit deny all, right, or deny any. So what does that mean? That means that when you're creating your ACLs, you want to make sure that you understand that at the end of that ACL, the very last entry is always going to deny everything. So if it doesn't match, and let's come over here and take a look. In our extended ACL here, if it doesn't match sequence number 10 and it doesn't match sequence number 20, it's going to drop everything. Okay? So typically what you want to do, and let's go ahead and go in, let's modify this extended ACL 101. So IP access list, and did I misspell access? I did. IP access list 101, or I should say extended, and then we're going to put the number in, 101. I can now manipulate it. What we want to put at the end is we don't want everything else to be blocked. We want everything else to actually go through, because we're going to explicitly deny things here early on, and it's at the end of this access list where we're going to say that we want to allow everything. And so this is where I would say permit, and since this is an extended ACL, IP encompasses everything as a protocol, IP any, right? So that's the statement that we want to explicitly put as the last line in the ACL to allow all other traffic to come through. So what does this look like now? So we do a do show access lists. Now I have explicitly allowed everything, but know that there's still an entry here. It's implicit, it's hidden, you don't see it, that says deny IP any. It's denying everything. So that's why we put this entry in here, okay, to say permit everything, because we're going to explicitly deny things. However, we want to make sure at the very end that the things that we've explicitly denied, that all the other traffic is still allowed to go through, because there may be 10 or 15 PCs over here, right? We want to make sure that their traffic gets through, and that's where we would put the permit IP any. So let's look back at our scenario here. I still can't get out to the web server because I've got that explicit any. I never, the deny statement at the end, I never put an allow statement at the end here. So what if I were to do this? Let's go ahead and build on this scenario. I have another PC here, right? And the PC should show up here in a second. Where'd he go? Oh, it's way down here. So I have another PC here. Aha, PC3 and PC4. So we'll just use PC3 or PC4. So I have another PC here, right? PC4. And let's pull up his config. And we're going to say that he's going to be 192.168.10.20, right? So let's put an IP address on him, 192.168.10.20. That's the right subnet mask, and he is 192.168.10.1 for his gateway. So can he ping the default gateway, 192.168.10.1? And he can't, and talk about overlooking the most simple of things. Let's plug him into the switch. Let's get him in the topology here. I was in such a rush to get the pings to run. So we'll do a Control-C there, and let's ping again, right? We're going to wait for spanning tree. As you can see, it's orange, which means spanning tree is doing its thing. We do not have port fast on. So we're going to have about 30 seconds, and let's go ahead and talk about this. So 192.168.10.20. When he tries to get out of this network, we have an ACL applied here. Now, at its face value, that ACL just simply says deny 192.168.10.10 from getting over here. We don't see any other entry in there. If I do a do show run, do we see in access list 101, do I see a statement that tells me deny any that's going to block all other traffic? Do we see that? We don't. Again, it's not an explicit statement, it's an implicit statement, which means it's there whether it shows up or not. It's there, right? All right, so we've got our PC online. Our ping is going to work here. It is not going to work. What am I doing? 10.20. I'm overlooking something. Oh, we've got the ACL on there. So the destination host is unreal. I can't even ping there. So again, this ACL that we've applied, yes, this is correct. We're actually denying TCP host traffic from 192.168.10.10 over to the router that's going to port 23. However, the implicit deny statement at the end is also blocking everything else. As you can see here, PC 192.168.10.20, I can't even ping my default gateway, let alone can I ping 10.10? That works because that traffic goes through the switch. So I'm on the network, we're on the same subnet. What if I try to ping 11.10 over on that other subnet? No, see, and this is not what we intended. All we wanted to do was stop users from this PC from being able to telnet to this router. So this is where we need to modify that ACL. Now again, it's much easier to go IP access list extended 101 to get into the numbered and named ACL editor, right? To be able to edit by sequence number. So let's pull this up. Do show IP access lists. And actually, access list, we only want to see 101. Let's create some space here. There we go. So as you can see, we've got quite a few matches denying TCP traffic from host 192.168.10.10, trying to get over to 10.10.10.2. However, we don't have an entry in here that allows everybody else to get through. And the implicit deny at the end of this ACL is blocking all of my other traffic. So what do I want to do? We do a question mark. You can see here you got the same sequence numbers and everything. So if I do a do show IP access list 101, you can see that the first statement there is a deny statement. So we'll go ahead and we're going to put in here permit IP any, right? So if I do a do show access list, you can see that here's my extended access list. Sequence number 10 is going to deny that telnet traffic over to the router. However, sequence number 20 is going to permit everybody else, right? So let's see if that's true. So now I'm back on PC 192.168.10.20, which we've added in. Can he ping over to the host on the other subnet? He can. And so this is what that implicit deny all at the end, or deny any, that's what it's going to do, right? If you don't remember that it's there, it's going to block all other traffic. And so this is where the sequence numbers become very important, because remember, they're evaluated in order from top to bottom based off the sequence number 10, 20, 30, 40, 50, right? And at the end of every access control list is a single access control entry that basically is denying all other traffic. So again, if you don't explicitly allow the traffic through, it will implicitly be denied. Okay, so this is a great example of that. So let's double check. So if I'm on this PC, can I telnet to 10.10.10.2? I can, and look at that, I'm on router 2 right now. But I'm doing it from this PC. Our ACL is supposed to block only the user here. Only supposed to block this guy from getting there. So let's come back over here and let's see. Can I telnet to the router? I cannot telnet to the router, and that's exactly what we wanted to have happen. Can I ping out to the web server? Sure. So all of my other traffic can get out. So that's a really good look at extended ACLs. It's a really good look at standard ACLs. We talked about how to manipulate the ACLs, right? Whether we have to cut and paste everything and then remove it and then paste everything back in, or do we just go in and make the changes? So one of the things that we have not looked at, we looked at numbered extended ACLs, but numbered extended ACLs. Let's take a look at a named extended ACL, and we're going to do that in the context of this setup that we have right over here, because we're now going to see, hey, what is that cookie? What is that going to look like in my log message? Is there any value to that? What does that look like, and what can we do with that? All right. So I'm on router 6, and my boss comes to me and he says, hey, listen, I need you to block all users on the 4.4.10.0 subnet, or we'll say the .11. So this subnet right here, which we're simulating with a loopback address out here. So anything on that /24 network is not to have access to anything behind router 6. So any of these networks back here, which we're simulating with loopback addresses. So let's take a look on router 4 right now, and we're going to go from user exec into privilege exec, and then we're going to go into global config mode, and whoops, actually we'll just go from privilege exec, and I'm going to say, can I ping 6.6.10.6? I can, right? Now here's the important thing to remember, is that these ping packets, when you're on a router and you're basically generating these from the control plane, what is my source address? What's the source address of these packets? Well, the source address is going to be the address of the interface out which those packets are going to go. So when I say ping 6.6.10.6, my source address is actually this 10.46.46.4 address. So how can I see that? So let me come over here. We're going to go ahead and debug, right? Remember, the debugs give us a lot of very valuable information. So I'm going to debug IP ICMP, and I'm also going to debug IP packet, right, on router 6. And as you would expect, right, we're going to see we have OSPF is still running. So we're seeing a lot of traffic that's being sent out from the OSPF process. But let's come back over here to router 4. So now, if I say ping 6.6.10.6 and I hit enter, and then I come over here, let's do quickly, we're going to do a view all, stop all debugging, and we'll scroll back up a little bit here. Excuse me. All right, so it looks like it starts. So here's where we were looking at some of the ICMP messages. However, this is where we start with our ping. And it looks like it starts right about there. So if we take a look at this, you can see that my ping, my ICMP packet, the echo reply, there's an echo request further up here. Did it pick that up? It doesn't look like it picked it up. So, but the echo reply is coming back from 6.10.6, and who's the destination? It's going to 10.46.46.4. So you can clearly see here that when you're pinging, and again, this is control plane traffic, right? When it goes out, it's going to have the source address of the interface out which that traffic would exit. And in our case here on router 4, that interface is this FA00 interface right here. And that's why you see that the source it's coming in from is 10.46.46.4 going to 6.6.10.6. So now that begs the question, how am I going to simulate traffic going from this is the source, 4411 dot whatever, in this /24 subnet? How do I simulate that traffic? And that's where we're going to use a little extended command here. We're going to add on to 6.6.10.6, and I'm going to say, if you look, you've got some choices here. Source. So let's change the source of this packet, and let's make it 4.4.11.4. Right? And then we have some other options here, but we'll leave it at that. And I'll hit enter, and you can see those packets went. And let me turn debugging back on, and I think all I need is debug IP packet. I think I'll turn on the ICMP as well. And let's run that command again. And then let's jump over here and let's quickly do a all, and we're going to stop debugging. And let's come back up. So as you can see, we've got our check here. So here's the ICMP echo reply. The source, now this is from router 6's perspective, right? He's replying to that echo request. And who's the destination he's replying to? 4.4.11.4. So by changing the arguments here on the command line and telling the ping command, hey, I want you to fake like you're coming from this source network, right, or that source address. And we can see that that works, right? Right over here, it certainly worked. You can even see that it was seeing the source of that ICMP echo request packet as 4.4.11.4 and going to this destination. All right, so now we're going to go ahead and we're going to take a look and see what it looks like when we tag some of these ACL entries and what those look like. So your boss comes to you and says, hey, listen, the senior guy's gone. I need you to block all traffic from that subnet. So we're going to block everything. Block it all. From this subnet, trying to get to any of those networks right there. How are you going to do that? So one of the first things we're going to do is we're going to go from privilege exec to global config, and I'm going to go ahead and say IP access list. So we're going to do a named extended access list. And you can see that's what the word option is for right there. And again, if I were to say, if I were to say standard, right, I can give it a name, but I can also give it a number, and then unfortunately the number is simply, that's what you see as the name. So you can give it a name, right, by using a word. If you use the number, then the number is used as the name, right? All right, so we're going to do an extended access list, and we're going to call this block underscore 4.4.11.0 underscore, and we'll say traffic. All right, so that's going to be the name of this extended ACL. And I'll hit enter, and you can see we go into the sub-configuration mode for an extended named ACL. So what are we trying to do here? Remember, we want to explicitly deny things first. So I know that I want to deny all traffic. So what can we pick from? Remember that IP encompasses everything you see listed there. So if I try to deny IP, that's going to block everything. And that's exactly what we want. So I'm going to say deny IP, and it's not going to be from the host. We're going to use the network statement. So we'll say 4.4.11.0. And now, do I need a wildcard mask? I sure do. And that's a /24 up there. Going to who? Or to whom? So it's going to the 6.6.10.11 and .12 networks. So we would be safe to say 6.6.0.0 and then give it a /16, because it'll block anything. 66 dot anything is going to be blocked there. And do we want to specifically block something in particular, or do we just want to log it? And so I'm going to go ahead and log, because we've already said IP, right? IP is everything, which is why we don't have an equal to some sort of a protocol there, or a port number. So, and here's where I get to put in my user-defined cookie. So this is where we want to say, or I guess we can just say deny 4.4.11.0 net _ traffic. All right. So now we may also want to put a remark in here. So I'll put a remark. Let's say that this was part of change control number 8675309, and Jenny said to block all traffic. And that was on 11/27/2014. And that is my remark, right? So if I do a do show run, take a look at the section where we have access lists. Let's see what we've got. So now it's kind of jumbled together here, right? But right at the very top, excuse me, right at the very top, you can see here is my access list, right? This is the named extended access list. There's the name of the access list. There's my deny statement, right? I'm denying IP, right? I'm blocking all traffic. And here's my remark. Now, again, always do sort of a mental check at the very end. Is there anything I'm forgetting here, specifically with that implicit deny? So if I were to go ahead and jump on to interface FA0/1 and do IP access group, and remember, we have to put the name here, so it's going to be blocking that traffic, say copy and paste. If I apply this on that FA01 interface in an inbound direction, it's going to block far more than just that. Because remember, we're not saying we're going to permit everything. So let me go ahead and put that on here, and let's see what the side effect of this will be. So up here on router 4, if I try to ping, and we'll say 6.6.10.6, and OSPF may be rerouting me here shortly. But as you can see, it's not working, right? No success rate. And it shouldn't be blocking the control plane traffic ping, because we saw that the source address of that is 10.46.46.4, yet it's actually blocking it. And that's where we would want to make sure we remember to say, oh, that's right, I need to make sure I permit everybody else just blocking. And now you can see it's actually blocking OSPF traffic as well, right? So on this interface right here, when we applied that ACL inbound, right, that's the right direction and that's the right interface. We just had one slight oversight, and that was the last deny all, right? At the very, very end where everything is being denied. So there'd be like a deny IP any. So what we need to do is we need to edit that access list. So if I do a do show access lists, right? you can see here's my extended named ACL, and I've got my cookie, my tag, that in case we get any hits, this is going to get logged, right? So let's see, am I getting any hits? If I do a do show log, are we getting hits? And if we are getting hits, those hits, if they're specifically coming from the right IP address, which is 4.4.11.0, would be blocked. So you can see we're getting tons of hits, right? It's logging it, but it's not tagging it because these matches here, the source address for these matches is not the source address of 4.4.11.4. That's not that is not that isn't what's happening here. So let's do clear log. So I'm going to clear my log, and now if I do a do show log again, do we have log messages? Nothing yet. We should have some here shortly. We don't, right? Because we haven't, nothing's matching that first statement. So again, when I do the do show access lists, you can see that in this statement, what's going to get logged? Only traffic, IP traffic from that subnet to that subnet, that's what's going to get logged. If it's coming from the control plane, it isn't going to get logged because the source is different. So let's go ahead and let's see if I were to type in here, or actually, before we do that, let's fix this ACL, right? It's going to bring OSPF back online. So we realize at this point, hey, I forgot that I've got that deny any at the end. So let's go ahead and say IP access list, or not access group, I'm sorry. And I am in interface subconfiguration mode. Let's get to global config, and let's type in IP access list extended. Actually, we need the name in there, and the name is blocking that traffic there. So we'll copy and paste. And now I can put in a statement here where I'll say, and you can actually go up in terms of the sequence numbers, they go up pretty high, right? So if I thought I was going to be adding in tons and tons of statements to this ACL at some point, the sequence number that I would want to use for my catch-all at the very end, so that way I don't end up having to rearrange things, let's use the maximum statement to say we're going to permit IP any, right? So now if I do a do show run, or I'm sorry, a do show access list, let's see what we've got. You can see down here the last entry is going to permit everything, and we've already got 6 matches, right? So we've got success. In fact, as soon as we turn it back on, you can see the neighbor relationship between router 4 and router 6 came back online because now we're allowing the other traffic. And so the reason I put this here, right, use this one, is we're putting it at the very, very end. But remember, right, even with that statement here, if let's say this didn't permit everything, if this was only permitting certain things, even with that access, the sequence number, there is still a deny all at the end of this access list. The reason I use this maximum value here for the sequence number is maybe I want to add in a bunch of other access control entries between 10 and that number, and I don't know what that number's, and I don't know how many ACEs it's going to be. Let's just put the maximum in there, right? Put this maximum number in here for the last permit any, and then I can go about my business doing 20, 30, adding in other ACEs in between without having to reorder the statements that are in there. All right, so now traffic is flowing again. Our OSPF neighbor relationship is up. Let me ping 6.6.10.6. All right, it works, right? It's fixed because traffic from other sources is being allowed through. Now, let's go back to the example where we wanted to change. Now I want to fake it out, right? I'm going to simulate that this ping traffic is actually coming from the blocked network segment, and we'll say from host 4.4.11.4, And we want to repeat this because I want to have a whole bunch of traffic generated here. So I'm now pinging. You can see the traffic is being blocked, right? Because the source address is specifically coming from this source. And so to wrap up, there it is. That's exactly what we're looking for. So you can see that it's generated a log message, a security log message, right? Level 6, IP access log, right? Block. There's the name of the access list, has denied ICMP traffic from source 4.4.11.4 going to 6.6.10.6, one packet, and most importantly, here is our tag. So whereas before we had all those entries in the log on router 6, when I do the do show log, we had all these other entries that were in there. I want, like, here's the OSPF entry. I want a static, dependable, hard-coded tag for that access control entry that if I come in here and search for it, I know what I'm searching for because I've previously defined it, and it shows up right here. So if I was using grep to come in here and take a look, it would work beautifully for me. And then I could tell you, hey, listen, we've had at least one packet come through. Now, clearly more than one packet has come through. So when this ACL is getting, this ACE or this ACL and specifically the ACE is getting hit with traffic, you'll notice that it's only told me that it's been one packet. However, that will change. If I do Control-Shift-6, right, and I break the pings, you can see that we had 112 packets. We were 0 for 112, right? And this ACE is doing exactly what I expect it to do. What will happen eventually over here is we will get an update to both the log, right? You'll notice it still only shows one packet, but we know there were far more than, it was far more than a single packet. It'll update. So while it's updating, let's make sure we prove, what if I tried to ping from the .10 subnet? Whoops, Control-Shift-6, the repeat we didn't need. So if I wanted to, let's say repeat 10, right? So it works from the 4.4.10 subnet. What about the 4.4.12 subnet? It works. So again, that extended access list allows us to use the source IP and the destination IP in concert, right? Now, I put it here on router 6, but since it's an extended access list, where should that access list be? Extended access list should be as close, as a general rule, as close to the source as possible. So if I was doing best practices, I'd want to put it here. However, we just ended up putting it over here on router 6 because we had some things that were already configured that we wanted to take advantage of. So back on router 6, you can see that it hasn't updated anything yet. Let me end. Let's do a write mem, right? Save our config because we want to save that access list. If I do a show log, let's see if it's updated at all. No, it hasn't yet, but eventually it's going to, and I'm not sure if it will by the time we're done here, because for right now, that's it, okay? So that is a very comprehensive explanation of ACLs for IPv4. Again, I'm going to bust this into two videos, one for IPv4 and one for IPv6. So what have we talked about, right? Let's go ahead and review what we've talked about. I'll leave router 6 up here in the hopes that we get that error message up here while I'm talking. So we talked about standard access lists and we talked about extended access lists. The standard access lists are either 1 through 99 or 1300 through 1999 when you're using numbers. When you're using a name on a standard access list, you can put the number in there if you want, but that kind of defeats the purpose. You can put a name in there as well, and that's what you would want to use for a named standard access list. Extended access lists, exact same thing. You can use names and numbers, right? Remember the difference between a standard an extended access list, or I should say the difference between a named, we'll do it over here on router 4, the difference between a named access list and a numbered access list is for a named access list, you want to start it with IP access list, and then if I did standard, that's where I can provide a name. So I could say standard ACL block all, right? And then I could add my entries in, you know, permit 10.1.1.1, whoops, or deny. And if I want to deny everything, it's just deny any, right? So there's a standard named ACL. We looked at the extended named ACLs. We looked at extended numbered ACLs, remembering that the extended numbered ACLs are 100 to 199 and 2,000 to 2699. We talked about the placement of the ACLs. All right, fantastic. That's what I was waiting for. So as you can see there, it finally updated, and it showed 111 packets. Because remember, what did this show over here? It showed how many? 112 total. It caught the first one here and was smart enough to say, hey, I'm getting a bunch of packets flooded in here. I'm going to wait till this is all over with. And then there's the other 112, right? So my show log, beautiful, okay? And again, there's my cookie, there's my tag in my log, so that I can easily sift through this log if I'm logging a whole bunch of other things and identify that entry. So again, standard ACLs, named ACLs. We looked at the placement of the ACLs, right? A general rule, right? It's not a hard fact it has to be. It's a general rule. Standard ACLs, you want to place those as close to the destination as possible. Extended ACLs, we want to place those as close to the source as possible. And again, we looked at net masks, how to calculate the net masks, how to calculate the wildcard masks using the net mask value of all 255s. And we looked at summarization again, remembering that when you apply that wildcard mask, that it is representing, in some cases, could be representing more than just the subnets that you think you're blocking. And so that's where you need to take a look at the summary address and sort that out and figure out what that is to see, hey, how many subnets am I actually blocking here? Or is it just the subnets that I think I'm blocking? Because in some cases, you can't use a single ACL to block only certain subnets, right? Sometimes it requires multiple ACLs. Or I'm sorry, multiple access control entries in your ACL, because the wildcard mask is actually grabbing more subnets than you actually think that it is. Okay, so hopefully this is cleared up and given you some really good examples on access control lists with IPv4. And the next video that we're going to do is going to be on access control lists for IPv6. All right, have a great day and a happy Thanksgiving.